Hi folks. So today is supposed to be box project part 2. It is still right here, not working very well. I haven't really touched it since the last time because I wanted to be able to do it on screen. But I'm doubting my ability to do it on screen. I'm going to give it a try today. If it doesn't work, then I am going to go and maybe make it off screen and take some pictures, and then I'll do the coding part live next week. Just kind of weird and awkward, but we're gonna give it a try. So if you remember, I have this box that I want to open and close based on my servo motor here. And so what I really want is I want to mount the servo inside, so when it moves, this part will be down, right? And then when it pushes up, like so, the box will open, and when it goes down, the box will close. That's really all we're going for. But this is too short, and this is the servo that comes in the kit. If I was at school, I would probably just go use a bigger servo, but this is the one that you have, so this is the one I'm going to make work. So what I think I really need is I need a longer arm on here. And I was really thinking what would be perfect is a popsicle stick, but I couldn't find one. I have some toothpicks, which I feel might be the right length. Like I think that that is a big enough length extension that would be helpful. But I don't really know how to connect those well. See, I have these little holes that'll take a screw, right? But I don't think I'm going to be able to screw into a toothpick very well. I don't really think that's going to work. I also found a clothespin, and I thought first, oh, well, I'll just like clothespin it off, and we'll see. No, that's not going to work because it just falls off really easy. But it is made of wood, and it's thicker, right? So maybe I can screw it onto that little thing, but I don't really need the clothespinny part of the clothespin. So I'm going to take this apart. Okay, so I really love clothespins. It's sad to take them apart. They're fun, but I'm going to set that part aside. And this is the part that I'm going to try and use. So I'm going to try and screw this on here like that, I think, maybe like that. And that's going to be difficult to accomplish with it attached. So I think I'm gonna take this off. Okay, so I'm gonna try and screw it in place like this. Now your kit comes with a little baggie of toppers that we looked at last time. There's also some screws in there. There's two little black ones. They're so tiny, so tiny. There they are. Those are the two that I'm going to try and use. It also has this even tinier, shorter screw, which you use to attach the topper to the servo if needed. I'm hoping I'm not going to need that one. So I'm going to try just those two. Put the other little pieces back in the baggie. Ta-da! Fortunately, your kit also comes with a screwdriver. So I'm going to try and line up my little come into focus extension piece right there, and get it screwed on to 1/2 of my clothespin. We'll see how that goes. Oh, it's so hard to hold everything. Maybe I will try and set this down on a table while I'm screwing into it. So ideally, I want 2 screws, right? Because if I only do one, then that's just going to be a new pivot point for it to kind of twist around. So I really need to spread out the tension so that it can't just rotate around that one. Ooh, sorry, this is terrible on-camera behavior. You can't see anything I'm doing, but neither can I. All right, so even before I get it through into the clothespin, maybe I'm just gonna try and start these through the plastic, because that is proving troublesome enough all on its own. Very hard to do in front of camera, you guys. I'm trying, I promise. So if I can get this guy started at least. This does not want to get started at all. I might have to go raid my supplies for some other screws. Or maybe I'll glue this guy on. Maybe today, just to see if I can get it working, I will try and tape it in place. Whoop, there went that screw. I'm gonna try taping it in place just to see if I can get it going so you guys don't have to watch me attempt to screw something in for the next 20 minutes. That's kind of what we're going for. It's not super strong, but it's not terrible. I'll add a little bit more. Okay, so let's see. I was gonna try and get this guy mounted inside, and I don't remember which way I left it facing. Like this, maybe? Okay, and so when it's all the way down, I want it to be like that. And then when I tell it to turn on, right, it'll go and turn all the way up like that. And hopefully that part will have the box lid be open. And when I turn it down, that will let the box lid be closed. Let's go see if it theoretically works. Okay. Down. Turn it to open. Okay, so if it was working, I would have this in there, and this would be up, like open, like part way, and so I think I need to turn this because I think that it's going to do better if I can mount it flat against the back wall. Now this, let's see, this would be like halfway. That would be up. Oh my gosh, guys. This box lid is too heavy for this poor little servo. This is what I'm gonna do. Today, I am going to do some Arduino programming in preparation for when I have a box with the servo attached. And then I think I'm gonna have to build it off camera. I don't think I can do it in front of this particular setup we've got going here. So let's take just a second, and I'm gonna go get an Arduino program started instead. Okay, so now for this today, I am going to start out my Arduino sketch. And then I'm going to come back with a spiffy looking box next week. And we'll kind of take it from there, and we'll look at programming some new interactions, and I will show you the box I came up with and how it works and how I attached everything. I just don't think I'm going to be able to do that in this little box we've got going here. Okay, so for today, share. Here we are. This is a nice blank Arduino sketch. We are going to make it a little bigger so you can see what the heck I'm doing. Okay, and I know some of the things that I'm gonna want, right? What always goes in the top of our programs, always, always, always. A header, that's right. It is the 28th today. Whoops, not of February. There goes my mind. This will be a useless box program, and non-commercial, by attribution, share alike is my license of choice. So what are some things I'm going to need? I know that I'm going to need a servo, right? And so I know I need to import the servo library. .h? That's not what that looks like. It's not import on these, it's include. Servo.h. You know what? I don't have all these things in my mind all the time. I'm gonna go look it up. And I just realized that it would be more helpful if you could see my whole screen. There we go. So let's go to Arduino's site and servo, right? And so these are the functions that the servo library comes with. And oh, it's a capital S and it's in brackets. Of course it is. So I am not here to tell you that you need to perfectly memorize the exact syntax for every language you're ever gonna know. It's just, it would be really, really hard. What's really important as far as I'm concerned is that you know how to find the information you need when you need it. Like that, okay? I knew that I needed to include the servo library. I did not off the top of my head remember just the right syntax. Fortunately, it's really easy to look that stuff up. This is the day of Google and the web, right? Right. Okay, and then I know that first thing I'm going to need is to attach, right? So if you remember, you could look up an example either on the Arduino website. There are some examples here just on that last page. There's also the SparkFun examples. If you've used a servo in the past, you could certainly go reference your old code. Those would all be great places to get started if you don't remember quite how to start. But here you go. This is how we're gonna attach, remember? So first we're gonna make a myservo object, and then in setup, we're going to attach it based on what pin we're on. So let's go back to Arduino. Here, let's just side by side these guys. Okay. So up here, I don't want to call it myservo. I'm going to call it servo 1 just in case I add a second one for some reason, because that could happen. Maybe I want it to move in some other way. And it's servo 1 attach. And this one is recommending pin 9 in their example. Pin 9 is a one of those pulse width modulation pins that's got the little wavy tilde in front of it. And I can't think why that would be a problem. So I'm gonna go with it. We're gonna use pin 9. Okay, and let's think about the types of things that I am going to need to be able to do. So especially when starting out a new project, I really want to include a serial monitor so that I can watch what the heck is going on. When I first plug in a servo, I want to be able to test it, right? When I first plug in a button, I want to be able to test it, or any sort of sensor. If we end up having lights, I want to be able to test those. The serial monitor is just a really great way to see what input you're getting and giving. Just in case there's something going wrong with your physical hardware, the serial monitor will at least let you report what the program is seeing at a given time. Okay, so down here, I think that I'm probably going to have, what did I say I was going to use? I was going to use some sort of input, right? I'm going to use the ultrasonic sensor. I think I was going to use the ultrasonic sensor because this was going to be when someone comes close, the box closes and then it opens so you can see the good thing. But yeah, when you come close, it closes. So I am going to need an ultrasonic sensor. So I'm going to need ultrasonic sensor. And that one also is going to need a pulse width modulation pin, and I think it actually needs two. I think it needs the trigger pin and so I used 3 and 4 last time. Except I don't think I did it like that. I think I said trigger pin was probably 3, and oh, what the heck was the other one? Let's go find out. Ultrasonic, oh, Arduino, ultrasonic sensor. Sure, let's go look at this one. Okay, so that's the exact sensor that I have. Let's see. Ta-da, looks very similar. And it does have trigger and echo, just like that one. And looking good. And I don't think, let's see, do both of them need to be pulse width modulation? No, they do not both need it, just the echo pin. So trigger, we can make 4, and echo, I'll make 3. There we go. Okay, and I can certainly set these to be constants because that just lets it know that I can't change these later. And I don't want to change them later. I'm only going to plug in the sensor in one particular configuration. Okay, so down here, I also need the pin mode, and I'm going to tell it that my trigger pin, I think the trigger pin is the output, and the echo pin is the input. All right, and so when I come down here into my loop section, you can see exactly how that trigger thing works. I don't know if you remember this. So we turn on the ping pin to low, we wait, we turn it on to high, we wait low, and then we listen to the echo pin, right, to figure out pulse in what it read back. So I'm pretty sure that there's a good SparkFun tutorial, the ultrasonic sensor, which will exactly match your kit. Yes, there we go. This is the one I believe we used last time, right? So, well, so they used this time 11 and 12. Suppose I could change that since I haven't actually wired anything yet. So if I'm going to reference this, I'm going to make sure that I go back up into my header and reference it. Referenced ultrasonic setup from SparkFun SIK version 4. This is project for 3B. And so the trigger pin and the echo pin, I did that. Setup, trigger pin, echo pin, I did that. Distance, okay, so they ran theirs in a get distance function, and I like that idea. So we are gonna go take this guy, and drop that function. But first, let's go make sure we know how it works, okay? Okay. All right. So the get distance function, float out here means that it is going to give us back a decimal number. We are setting up for the use of this function only an echo time and a calculated distance. We are telling it to turn on the trigger pin, wait for 10 microseconds, and then turn it off. So that's that kind of sending that pulse. And then echo time is we are waiting for that pulse to come in on the echo pin to trigger it to high, and then using this to calculate that distance. See that? Okay, and then return calculated distance means that when I call this function, this is the value that it's going to give back, that calculated distance, not the time it took for the echo to come back, but the distance that has been calculated based on that time. So way back up here, I'm going to say, you know what's one thing I'm going to need? I'm going to need a float to hold the distance value. And so the first thing I will do when I run my program is I will run the distance function and store the result in that distance variable. And then probably the next thing I'm going to do is print it out. And maybe I'll do it like this. I will print distance. And then distance. So you may be wondering why the heck I would do that on two different lines. And it's because Arduino C has a kind of hard time sticking text like a string, right? Like this part right here, this distance in quotes. It has a hard time sticking it together with this float. But it can print out both of them. So if I just line them up like this, that is going to go a little bit better for us. Okay, so I am short on comments right now. Get distance from the ultrasonic sensor and print it out. Cool. I also up here, I think I want a variable that will be close value. So this is going to be a number. I don't know what this number is going to be. 50. 50 is a nice round number. For like the trigger that I want to set up for if someone is within 50, it'll close. Okay. And then if not within 50, it'll open. So I'm going to go down here and kind of set up the structure for that. If distance, distance is less than the close value, close box. Else, open box. Right? Right. Okay. Let's see. I'm going to go back to our servo options here because now that it's attached, I need it to write. There we go. So this is how we tell our servo what to do, right? This 90 would be the midpoint. I'm pretty sure the midpoint is going to be open. So down here, I will say servo 1, write 90, and close. I think I visualize this one. I always get this backwards. There it is. So if the midpoint there is 90, I'm pretty sure the way I plan on mounting it in there down like that will be 0. So I could be totally wrong. It'll be 180. So we'll see. All right. So this is pretty close to a done program, minus the fact that I don't have a box to test it on. So what does this say to do? So this sets up the servo and ultrasonic sensor. This is variables to hold values. I don't know. That's not very descriptive. The setup section, fairly self-explanatory. Here, I'm going to get the distance from the ultrasonic sensor and print it out. That's what this section does. This section, see if something is within the close value distance. So if it reads something within the close value, it's going to close. And if it doesn't, it will open. Okay, that's pretty complete right there. And we went and are using the get distance from the SparkFun example, which is why I made sure to reference it right here, right? Reference your sources. Okay, in fact, if anything, I'm going to go one farther and make sure that I include their website in case anyone else wants to go read that reference as well. All right, so I'm gonna pause there. This would be the point where I would want to test my setup on the box. So for next video, next week, I will make sure that I have a box with a servo and an ultrasonic sensor attached to it that kind of move, but I'll save the testing for you guys. And if it works, then we will go about making it a box with a little more personality. Maybe it has more than one set of reactions. Okay, so that is my plan. I'm going to make sure to save this. Useless box. Excellent. All right, we will pick up there next time. Have a good one.